we will be going through 2011 A-Maths 10-year series, paper 1, question 2. In this question, they've given us one angle. They tell us also that B is a right angle, M is the midpoint of AB, and the length of AC is 8 meters. So we are supposed to show that angle ACM is inverse of sine root k over 14. Now what this means is that if we work backwards, as long as we are able to write sine ACM equals to root k over 14, then we will be able to take sine inverse and show that and the angle is equal to sine inverse root k over 14, and we can find the value of the integer k. So right now, this is our goal. So identifying the angle ACM is over here. To find the sine of this angle, we see that it is not part of a right angle. So we cannot use our basic trigo ratios in order to find an expression for this angle. So we need to make use of something else that we have learned. So we can consider, for example, area of triangle, half AB sine C. That's when the sine of an angle appears. We can consider sine rule. We can consider some of the trigo identities that we have also learned. Some of trigo ratios, trigo ratios of the sum of angles, for example. So these are the things that we can play around with. Now, as we continue, we see that this being a right angle, and given one angle and a hypotenuse, I should be able to find an expression for BC using sine of pi over 6 equals to BC over 8. So we have BC is 8 times of sine pi over 6. So that is one expression that we can have. So as long as we remember the trigo ratio for sine 30 degrees, then we will have the answer for sine pi radians over 6. That will be half times 8, we get 4. Okay, we can do something similar for the length of AB using cosine pi over 6 is equals to AB over 8. So from here, AB is 8 cosine pi over 6. Now cosine pi over 6 is actually root 3 over 2. So 8 times of root 3 over 2 gives us 4 root 3. So that's the length of AB. And since M is the midpoint, then MB must be 2 root 3. And this is also 2 root 3. Now what's the point of having all these? We also see that triangle CMB is also a right angle triangle. So using Pythagoras, we will be able to find the length of CM. Now that we have the length of CM using Pythagoras, we can then consider using our sine rule, which states that sine of this unknown angle that we want divided by the opposite side, which is 2 root 3, is equal to sine of another angle in a triangle, which in this case we can use pi over 6, divided by the opposite length, which we mentioned we can find using Pythagoras. So let's try this approach. Copy down all this. Okay, and now we will apply our sine rule. Sine of the angle we want, ACM, divided by the opposite length, so 2 root 3, has to be equal to sine of the other angle that is given to us, pi over 6, divided by the opposite length. Now the opposite length, as we mentioned, using Pythagoras, we have square root of the sum of the squares of the other two sides. So let's have 2 root 3 square this plus BC square. Okay, so here we end up with sine of ACM multiplying both sides by 2 root 3. Now in the fraction, sine pi over 6 is half over, inside this square root we have 4 times 3, which is 12 plus 16. Okay, so let's multiply numerator. Let's multiply the 2 root 3 to the numerator. We end up with root 3 over root 28. Now root 28 we can factorize out 4. 4 times 7. Now square root 4 is the same as 2. So in the denominator we have 2 root 7. In the numerator we have root 3. Now our goal is to make the denominator equal to 14. So in order to make this equal to 14, I don't want this square root symbol. So what I can do is to multiply both numerator and denominator by another root 7. So in the numerator we are going to have square root 21. In the denominator it will be 2 times 7. So final answer will be square root of 21 over 14. And this is the form that they want. Sine of the angle equals to root k over 14. So from here on, we have ACM, the angle is equals to sine inverse root 21 over 14, and k must be equals to 21. The last question we are going through for this paper is question 13. We have a circle with this equation, and we need to find the coordinates of the center and the value of r. So as mentioned in the previous few papers, we can either memorize and obtain the x and y values from the coefficients of x and y, as well as the value of r from a combination of these three values. Alternatively, we can complete the square. So by completing the square, we will arrive at x squared. Let's group all the x terms together. Minus 6x plus y squared plus 8y minus 375 equals to 0. So let's complete the square for this. X squared minus 6x. So we plus negative 6 over 2 square. Take away whatever we have just added. So this is for the x squared and the x terms. And now we're going to work on the y terms. Plus 8 over 2 square this, minus 8 over 2 square this, and we're left with the constant. So now, here we have x minus 3, we square this, leave the constant to the back. Likewise over here, we will combine these three together. And over here, we've got y plus 4 square. So we have a sum of two squares. And now let's work on the constant terms. So the very first constant term that resulted from the x squares, we have a subtraction of negative 3 and we square it minus 9. Here we have to subtract 16 and subtract 375. So further simplification, we have x minus 3 square plus y plus 4 square equals to now 9 plus 16 plus 375, 400, which is 20 square. So based on this, we know that the center has coordinates of, change the sign of this negative to become positive, so we have 3. Change the sign of this positive 4 to get negative 4, and the radius equals to 20. So that is for part 1. Okay, now in part 2, they tell us that the point P lies on the circle. Whenever the question tells us that a point lies on a line, lies on a graph, lies on anything, you have to realize that they're telling you to substitute this into the equation. In this case, it is the equation of the circle. If they tell you that a point, negative 9, 12, lies on a parabola, then you have to substitute it into the equation for the parabola. If they tell you it lies on a straight line, then you have to substitute this point into the straight line equation. So let us go ahead and do that. We earlier found that the value of the equation can be written as x minus 3 square plus 1 plus 4 square equals to 400. Okay, so we can substitute this x value here. We can substitute the y value in. Okay, so we can substitute this value of 12 inside here, and we'll find out that the left hand side equals to 400, which is equals to right hand side. Okay, so this will allow us to verify that this particular set of coordinate indeed lies on the circle. But today in this case, it is not necessary because there's no unknown for us to solve. So let us make use of the next piece of information. They want the line CP. So C, we found it. P, we've got the coordinates, which means that I can find the equation of this straight line by finding the gradient, then by finding the y-intercept. But over here, we expect the y-intercept to be equal to 0 because they want us to show that it passes through the origin. So let us start with the gradient of CP. Using y2 minus y1, so negative 4 minus 12 over 3 minus negative 9. Here we obtain negative 16 over 12, which is negative 4 over 3. And we substitute this into y equals to mx plus c. We choose a value for a coordinate that we want to use. Either choose point C or point P. So for example, let's choose point C. So the y value equals to the gradient, negative 4 over 3, times the x value plus c. So here we see that negative 4 equals to negative 4 plus c, so c equals to 0, which means that the equation of CP is y equals to negative 4 over 3 x. It does not have the value of y-intercept over here is 0. Okay, so over here it is now shown that CP passes through the origin. Since the y-intercept of CP is 0, it passes through the origin. There are other approaches you can choose to solely consider the gradient and to prove that there are the 3 points O, C and P are collinear. That is one way to do it also. Now next, for part 3, to find the equation of the circle for which OP is a diameter. Okay, so we've got the coordinates O, which is just 0, 0. We've got the coordinates P. So if OP is the diameter, then the center of the diameter, or rather the midpoint of the diameter, has to be the center of the circle. And we know that to find the equation of a circle, we definitely need the center, the coordinates of the center of the circle. So there's one thing we can find out quite easily, midpoint of OP. The next thing that we need is the radius of the circle. So since OP is the diameter, then the length of the line segment of OP, we divide it by 2, we get a radius. So that is going to be our approach. So midpoint of OP equals to center of circle. The midpoint of OP, 0 plus -9/2, 0 plus 12/2. And so our center is -9/2 and 6. Now we need the radius. It is going to be half of the length of OP. So -9 plus 0, or rather minus 0, but it doesn't matter. We square it, we add that to 12 minus 0, we square this also. So we have 81 plus 144. This is 15/2. That is our radius. So combining this information, the equation of a circle will be x plus 9/2. We change the sign for this, square it, plus y, again change the sign, minus 6, square it. You get 15/2, and we square this. All we need to do right now is to evaluate to the 5/4. Over here we can expand and simplify, and our final answer would be x squared plus y squared is 9x minus 12y equals to 0.